And finally, the most important device and the most important portion of the app is the battery monitor. In this system, it's a Victron BMV 712. This part of the app, as well as the physical device display, shows you the state of charge, battery voltage, current in DC amps, and then some other stuff that's somewhat important, but we'll go over it in a second. So here in percentage, this is your state of charge from 0 all the way up to 100%, just like your phone or your laptop or anything else. You can technically go from 100 all the way down to 0. One thing to note, most of the installs we're using Battleborn batteries, and they will shut down at 10.5 volts. That does not necessarily equate to a specific state of charge. Generally, it will be somewhere below 0%, or maybe in the single digits. It sort of depends on the loads and the current condition of the system. So, the next is voltage. And unlike AGM systems, voltage isn't terribly important anymore. The only thing really to watch for is, say maybe this says 100%, but your voltage seems awful low, maybe 11 volts. You'll never truly see a 100% system with something like 11 volts. So that is indicating maybe something's wrong. Most of the time, you can basically ignore voltage. The next most important number is this number right here, current in DC amps. And that's net current in DC amps. It's everything coming in minus everything going out into the batteries or from the batteries. This includes solar, DC-DC charger, power coming in from the inverter charger, or power going out to lights, fridges, microwaves, air conditioners, whatever. It includes everything, but it does not know where it's coming from or where it's going, just which direction it's flowing and how much. This is actually how the app calculates how much power is in the batteries. It just counts this over time based on the battery bank size that we set in the settings for you. So currently we have probably 50 amps. No, we probably have 30 amps coming in from the solar. But this says 27. That means somewhere in the system we're pulling 3 amps out. Like I said, it's a net number. Everything coming in minus everything going out. This state of charge, it shows you where you are. This current, it shows you where you're going. Right now, it's a positive 27 amps. So we can see that the system is charging at 69%. That means it's going up fairly quickly to a higher state of charge. If I turn on a large load, we'll see it go to a negative number. Now I've turned on the air conditioner, and you saw it go to a smaller positive number as the fan kicked on, and then once the compressor kicked on, it used up all the available power coming in from solar, and now it's also taking power from the batteries. So now the battery bank is going down at 66 amps every hour. So if we leave it this way, eventually this will start going down all the way to 0 until the system dies. Unless we turn the air conditioner off, or start the generator, or provide more power coming into the system. And now I've turned the air conditioner off, so now the solar is charging the batteries again. This number here is power in watts. It's essentially just this number times this number. Then right here, consumed amp hours is the number of amp hours consumed since the last full charge. This will actually count backwards when you're in a draw state, or it will count back towards a positive number, well, technically 0, when you're charging. It'll actually count back up. This number will get smaller. If we watched it long enough, it'll go to negative 120 and eventually all the way back up to 0. Time remaining, currently it's basically giving us an infinite because we have a positive number. I find this number to be basically useless. The system only averages over a few minutes, and that's just not realistic for a vehicle-mounted system like this. There are just too many constant variables throughout the day. Down here is this state is a relay control. Again, no relays in any of these systems.